Welcome to the Global List. This is the Global List, where we travel around the world on unexpected journeys with leaders, thinkers, and innovators. I'm your host, David Solomon Bassiouni, president of the Bassiouni Group, a global consulting firm focused on sustainability, innovation, and impact. Welcome back to the Globalist podcast and welcome to season 3. We want to thank you for all of your support so far. We're absolutely thrilled to continue this amazing journey with you, and we're also excited to announce that we're introducing a new rebranded look as well as a new YouTube channel at the GL Podcast, a new Instagram account at the Globalist Podcast, and a new TikTok account at the GL Podcast. As always, you can find the Globalist wherever you stream your favorite podcasts, including Spotify, Apple, Pandora, and beyond. So please follow our new social media accounts, subscribe, keep sharing the content, and we'll keep flying. Now, on to episode 1 of season 3, nuclear. The word alone can seem frightening. One immediately thinks of nuclear weapons, nuclear war, but there is another side to the coin. Nuclear energy does play a critical part in the energy mix as a source of carbon-free energy. And right now, we're in the midst of a so-called nuclear renaissance as we witness the emergence of small modular reactors, microreactors, new power stations, and hyperscalers, all emerging to meet ever-increasing energy demands, the massive surge in data centers due to AI, and, most importantly, the challenges posed by climate change. So, is nuclear energy the answer? Can it address some of the major concerns, fears, and doubts? What, in fact, are the critical innovations underway right now? And what key developments do we need to keep in mind? What are the challenges and opportunities? Our special guest today is Seth Grae, Chairman and CEO of Lightbridge Corporation, a Virginia-based company that's focused on developing advanced nuclear fuel technology and working closely with the U.S. Department of Energy on R&D. I will also note that Lightbridge, which was then known as Thorium Power, was the Bassiouni Group's very first client. So this is a full circle moment. Seth Grae, welcome to the Globalist podcast.
David, it's so great to be on with you. Thank you.
Great. Well, Seth, we're, as I said in the intro, we're in this sort of middle of this renaissance, and you've been in the industry for a while now. I think before we kind of jump into the deeper questions, I always want to find out, how did you get into the industry? What was it that drew you in the first place? And as a child, I'm sure you didn't wake up thinking, well, I'm going to be in nuclear energy. But what was it that pulled you into the industry, and what inspired you to come into the nuclear energy industry?
My graduate degrees are in law and in business, not in engineering or science. And I originally came into nuclear through the law. When I was in law school, I wrote a paper in the form of a brief to represent someone who was a nuclear engineer in the then Soviet Union, and ended up actually taking on that case and helping him actually get released. And through that, got very interested in talking to people around that case and things about nuclear. And then as a lawyer, I had worked on the international transfer of high technology that became only nuclear technology. And I was very intrigued in the nuclear technology, the people in the industry. They were just remarkable, fascinating people with remarkable careers, trying to do big things. There were some very interesting international aspects about the nuclear power industry to me. So that's really how I originally got interested into the industry, through being a lawyer.
Yeah, it's a different entry than the typical engineer, that's gone into, for example, nuclear fuel development and so on. But I suppose coming from the legal side, that also exposes you to different participants or different players in the industry, right? From fuel fabrication to research and so on, right?
That's very true. And it's a very law and rules-based industry, and understanding the legal framework, the regulation, from the US regulation to the safety culture to the rules around transferring the technology to protecting that intellectual property and contracting is all very relevant.
And when I mentioned earlier on that the word nuclear to many people can seem frightening, right? There's always that sort of there's always that fear that's associated with the word, because I think most people immediately, the mind goes to nuclear war or nuclear weapons, right? And you've been on the civilian nuclear side. all this time. And can you just, for the sake of the audience, just take a step back and kind of define what nuclear energy is in a nutshell, if you can, and why it's played a key part in the energy mix previously, particularly, here to some extent, but also abroad, particularly in Europe. But in a nutshell, what is nuclear energy and why is it important to consider it as part of the energy mix?
I try to avoid just using the word nuclear for exactly the reasons you're saying. People might hear the word nuclear and think of the word that follows it as being nuclear war or nuclear weapons or nuclear medicine. And if we're talking about nuclear energy, I say nuclear energy, or more specifically, I'll often say nuclear power. And I think of power as energy that is always available at the full amount. And that is one of the key benefits of it in a world with a lot of intermittent energy supplies, such as by wind and solar, that aren't available at the full amount if the wind isn't blowing or the sun isn't shining and might not be available at all. And for modern industries such as data centers with AI, they need tremendous amounts of energy that is constant, that's reliable, that's available all the time, and that also preferably is clean. And nuclear emits no CO2, it emits nothing harmful into the atmosphere, it emits nothing into the atmosphere at all. So nuclear is something that nuclear energy, nuclear power is something that I think is a very important part of the energy mix. If you're going to have a modern economy with a lot of always on clean power, you really can't get there without nuclear as part of the diversified energy mix.
You mentioned sort of the demands, right? The data centers and AI, that's a recent occurrence that's, continuing to surge, right, in terms of the need. Overall energy consumption needs are increasing as well. So that's a new sort of phenomenon. But of course, in industry as a whole has always had these needs, an energy consumption need. Why is it that in the case of the US versus, let's say, Europe, a country like France, where you have, massive investment in nuclear traditionally for decades now, and Germany to some extent until they phased it out. Has there been a slower uptake of nuclear here? Obviously, it's part of the mix, but has it been slower? And if so, why? I know obviously 3 Mile Island and other things happened, but what is it that sort of curtailed the full emergence of nuclear in the U.S.?
Well, the US has generated about 20% of our total electricity usage by nuclear for about half a century. And that's not bad within a diversified energy mix that has included hydroelectric and natural gas and coal and sometimes some geothermal and some other generation as well. And I think that one of the reasons why the US did not increase the amount of use of nuclear energy as much as some countries did is an abundance of resources in some other areas, such as the ability to have hydroelectric that some countries don't have. There was also, I think, an unfounded public fear of nuclear that in many ways is actually the safest industry in the country. And nobody has ever died from radiation in the history of the US nuclear power industry. Just as you hear if you go on a flight, it's the safest part of your day, and an industry that so prioritizes safety. Well, if you go on a flight to visit a nuclear reactor, you're really going to have a safe day. And it's everything in between that's statistically more dangerous, because this is an industry that focuses on and delivers on such a high standard of safety. And I think that you see that in communities where there are reactors. So the reason for this fear of nuclear power really traces back to 1979 to 3 Mile Island in Pennsylvania, with fuel that melted down. And this was at the time the China Syndrome movie was in the movie theaters. And this led to abandoning of large numbers of nuclear projects, canceling of large numbers of nuclear projects. Well, nobody died at 3 Mile Island. Nobody got killed at 3 Mile Island. And now, as there's such a need for surging electricity in the region, the remaining plant at 3 Mile Island is in the process of reopening with strong public support locally in the state of Pennsylvania in a bipartisan way, led by the Democratic Governor Josh Shapiro, and with tremendous national support led by the Republican President Donald Trump. And so, of all the reactors to be reopening and with such popular support, that it's 3 Mile Island, I think really shows how people have come to understand that we need nuclear as a growing part of the energy mix. And the fact that 100% of that power will be used for Microsoft data centers, just shows where the new demand is coming from and what they're looking for to how they can find that much power.
So that's a full circle moment there in itself too, right? If you're talking about 3 Mile Island historically has had this, sort of the black cloud over it, right? Historically, in terms of hanging over the industry, but now is in the midst of really being reopened. The Microsoft's involvement in there, and the term I've been hearing, I hear about hyperscalers and what Microsoft is doing within this context. So can you talk about that term, hyperscaler, and Microsoft, and then this PPA that they have with Constellation at 3 Mile Island?
Yeah, it's interesting because I saw today that the word hyperscaler isn't in the Microsoft online dictionary, but they're what a lot of companies think of when they think of a hyperscaler.
Right.
And I think the term mostly is being used now for these enormous companies, be they in the tech industry from the Microsoft angle, needing data centers and software, to the chip companies like NVIDIA, these $4 trillion market capitalization companies that are on the leading edge of many technology developments and usage in data centers for artificial intelligence. And what I've heard about NVIDIA and some of these other enormous companies like Amazon, Microsoft, Google's parent, Alphabet, and Meta Systems, which is Facebook's parent, is that perhaps the biggest limiting factor on their stock price going forward is their ability to get enough power for the data centers with AI. And in that context, it makes perfect sense to go and reopen 3 Mile Island, to find the power where you can, to build new reactors. They need the power to execute on their multi-trillion-dollar business plans. So these data centers, to put in context, New York City, all 5 boroughs, use about 8 gigawatts electric all of the time. Think of it every day. New York City is using about 8 gigawatts. There's one data center that Microsoft is planning to deploy with OpenAI that will use over 5 gigawatts for one data center. So one supercomputer complex, they call it, a campus of data centers. That's larger than the power needs of most major cities, and it's 5/8 of New York City's power needs, the largest city in the country. So these data centers just need power at a level that has been unimagined before in our nation's history, on how much incremental power you have to add to the grid for these data centers. And there's a notion that we're in almost an existential competition with China, that if the American and Western companies don't, in a sense, win the AI race, it would be very bad for the nation, with AI eventually being in almost everything from weapons systems to controlling the electric grid to ultimately in people's pacemakers and toasters and everything. But really, in big picture, AI is becoming very important for everything. And the most highly valued companies in the history of the world are the ones leading this charge and that need the most new power.
And so, I mean, that surge, which is, as you said, it's unprecedented, right? We're seeing AI itself is emerging and evolving in such a rapid way, but coupled with the ever increasing energy demands that it just, as you mentioned, the example between the demands of New York versus Microsoft's data centers, it's massive. And there is this term, I remember, hearing early on when we were getting our immersion into nuclear energy, and I remember the term baseload power, right? That this idea of sort of always on 24/7 power, and the sort of comparison between what you're able to generate in terms of nuclear energy power, what that can service in terms of communities and industry versus other sources. I mean, I personally, of course, always believed in all of the above. But can you unpack that term baseload power and what that means, particularly in the context of, AI and these data center and what the surging needs there?
Sure. So there's terms baseload power, and some people call it firm power. There's peaking power, and people talk about peaker plants. And you could think of, say, in a service area, say a city, the amount of power that is always needed, no matter what, at any time, be it at night or a weekend or in the spring or fall when there's not as much electricity or air conditioning being used. Think of that as the base load, that no matter what, that amount of power is always needed. And then everything above that, you're getting to more mid-level generation and peaker plants that kick in as you go up. So, for example, in New York City, there's even some oil burning plants that can kick in if the electric need surges on a hot day when there's a lot of air conditioning needed. Now, that's also called firm power because you need it to always be there. If it dips below that amount, the lights start going off, hospitals lose power. It's pretty bad. And so the base load, in a sense, is increasing. That line is going up of how much power you need for base load when you're adding data centers, when you have other industries like steel being produced with electric arc furnaces that are switching from fossil fuels to nuclear power. When you look at transportation like cars and buses and trucks that have been powered by fossil fuels in the form of gasoline or diesel that are switching to electric cars and electric vehicles plugging into the walls. And there's crypto mining where people are using electricity for that in large amounts with computers. And this is adding to this amount of always on electricity that's needed. So, for example, in Loudoun County, Virginia, which has more data centers than anywhere in the world near Washington, D.C., there's just this immense amount of always on electricity needed. And without it, the credit card payment systems wouldn't be working. People's photos from their phones wouldn't back up, and all kinds of critical national security missions wouldn't be going on. So having power that can produce baseload energy is very important. Nuclear is pretty much the best at doing that. And what you find when you build a reactor is it could last almost forever. You could keep refueling it, keep replacing the critical parts. There are reactors that were originally licensed for 40 years that have been relicensed to go to 60 years. They're being relicensed to go to 80 years, that some of them are already looking into going to 100 years. There's a joke in some of these plants that the only thing that's actually 40 years old at the end of the original 40-year license is the license on the wall. They've replaced so much of the equipment along the way, but they really become these almost forever generators of reliable power at a very known cost. And when you have fossil fuel costs being very volatile and could go up and down in price so much, versus it's expensive to build the nuclear plant, but then it's pretty cheap to fuel it for up to 100 years. That's just usually the best investment you can make in power generation. So nuclear is just increasingly becoming looked to for baseload power, for firm power, as we need more of it.
And do you feel that, we've seen it, you mentioned it earlier on, that now we're seeing a sort of a wave of actions take place. You mentioned some of the executive orders that President Trump signed. There's industry action going on, as you mentioned, 3 Mile Island and so on. Do you feel that there's a surge of activity here precisely because, one, it's to meet the energy needs, but also there is this geopolitical component to this, right? In terms of national security as much as it is energy security, right? I think energy security sometimes gets lost in the national security debate, right? Because, maintaining and making sure that there is a sufficient, energy mix, redundancy, all of those things are as critical, right? Just as U.S. is competing against China in terms of AI, it's also competing in terms of energy and climate transition and all of that too. So it seems to me that it's a critical moment both in terms of geopolitical considerations and energy security.
Yeah, I agree. And what I'm seeing on Capitol Hill is that this is probably the most bipartisan issue there is. Literally, support for nuclear power. It's just amazing how strong the support is from both political parties. And as we've transitioned from administration to administration, how strong the support is in the administrations. So we've seen, fantastic legislation supporting nuclear power. We saw in May of this year the president's executive orders. And there is a bit of a great power competition there. That this is the US and its allies versus China versus Russia. And industry simply needs the power. And without it, people's electric bills will keep going up. There won't be as many jobs. There won't be as many good jobs. The modern economy needs jobs that need a lot of power, from data centers to steel production to all these new factories we want to onshore in America, including auto production. It's just almost staggering how we talk to people at utilities and say the amount of power they need to produce 5 years from now is so much more than they were projecting 5 years ago for 10 years in the future. And now when they look at 10 years in the future, they really have no idea how they're going to get there from here and keep businesses, keep jobs, keep the air conditioning and the heat on. And, that's why they're investing in new energy deployment, including, in particular, so much interest in nuclear power.
And of course, when you look at the constituent parts of nuclear energy and nuclear power, you're looking at, you mentioned it, the investment, the upfront investment, recognizing that, investing in a nuclear plant is costly, but the sort of the overtime benefits in terms of energy generation, always on power, of course, the benefits there. There is, of course, the flip side, which is, yes, the demand is there, the need is there, the consumption is there, but there has always been this concern on the other side, which is, well, okay, what do you do about waste? How do you manage waste? How do you manage that? How do you control or manage the issue of proliferation and so on? And I know we're going to get into talk about what Lightbridge is doing with fuel technology, but at a high level, what can you say to those sort of criticisms about, okay, yes, nuclear does offer an answer, but the challenges with waste management, are they still there? What is being done on that side?
First of all, on the cost, it's more expensive to build a nuclear power plant than to build a gas plant or a coal plant. or most other kinds of power generating plants. But then the cost of operating the plant every day is much lower. The cost of the nuclear fuel over the life of the plant is much lower than the continuous cost of buying the natural gas or the coal. And it is not nearly as volatile in price. And overall, over the life of the plant, nuclear turns out always to have been a good investment. And, in fact, often the best investment. And for states, for countries that are looking at the long-term power needs, think of it like building the interstate highway. It might seem like an expensive thing to build if you don't already have an interstate highway system, but you'll be very glad when you have it. When you look back a couple of decades later, the benefits of it will tremendously outweigh what the upfront costs were. And economically will have been a fantastic decision to make. And nuclear waste is one of those areas where, again, like safety, I think there are some misconceptions. So for all of the nuclear power used in all the energy, all the electricity used in one lifetime in the United States, for everything attributable to one lifetime, uses nuclear fuel rods put into reactors. If it was all generated by nuclear, that add up to the size of a can of soda. And when you take the fuel rods out of the reactor, they look exactly like when you put them in. There's no liquid waste. And so all of the waste, in a sense, from the lifetime, if all electricity were, from all the factories that made your clothes to everything attributable to nuclear, be the size of a can of soda. And about 96% of that would be uranium, pretty much like what you could dig up out of the ground. So if you separate out the uranium, the other wastes in there are about the size of a pinball for all of the waste for one lifetime. And it's all contained in that solid form. So there's nothing in the ground, there's nothing in the atmosphere. It's very easy to safely handle. And in France, for example, they reprocess to reuse uranium and use plutonium that is produced too. That's about 1% of the waste. So there's only about 3% that they have to handle. It's called fission products and transuranics. And they mix that with other substances that they safely bind with into a glass log through a process called vitrification and bury it. And there's one room in France where under the floor is all of the nuclear waste in the history of the country. And it can't hurt anyone, and it's not dangerous, and it's not a weapons threat or anything like that. So it's something that can be handled very well. And I think that here in the United States, we're handling it well, where we take the fuel out of reactors and we put it in these pools on the reactor sites called spent fuel pools. And then after a few years, we put it into what are called dry casks, these steel and concrete casks outside on a concrete pad near the reactor, where they're very safe. You could go up and have a picnic next to those casks, and you won't get any radiation. In fact, you could go and stay there for a year and get less radiation than if you eat one banana once, because of the potassium in the banana. And then eventually these might go to what's called interim storage, where we'll have a centralized location where we put a lot of these casks, in one or more places, above ground in these concrete and steel casks. And then we'll either put them below ground in what's called a high-level waste repository, or reprocess and reuse most of that material in reactors to generate power again, with only these very teeny tiny amounts that we need to handle and bury underground. And even those materials for some of the newer kind of reactor technologies can be reused, or what's called, by the engineers, transmuted down to lower level materials. So it's actually technically not a challenge. It's more of a political issue. And again, when you look at these local communities around the plants, they've realized it, that this is not a safety issue to the community. It's not a health issue. There's no problem at all. So again, of all places, 3 Mile Island, Harrisburg, Pennsylvania isn't against reopening that reactor. And over time, putting more of these dry casks there on the site.
So in a sense, I mean, to play on the pun, the safety issue is more contained now, certainly than it may have been, 50 years ago? Is there been a change both in terms of the technology that has allowed for safer, let's say safer fuel management, waste management, as well as, regulations, both?
I think that the nuclear industry's practices and the regulations from the government, have been honed over the decades. But this is an area I think the industry has always handled well. Again, nobody has ever been hurt by this in the history of the United States. And it will be very hard to figure out how someone could be hurt by this, given how it's handled and how it's handled so well. You could find online some videos of people taking these casks that they put the casks into and, have the equivalent of fly a fighter plane into it and nothing happens to the cask, or have two locomotives crash head on into each other that have these casks on them. Nothing happens to the casks. But even if they cracked open, it's very unlikely. But in an instance like that, again, this is solid material that you could put back into a cask. So it's really not this big danger that some people think that it is.
And it gets us to the issue of the fuel itself, right? And what it is that's actually, the key component within a reactor. And I think it takes us to what you do as Lightbridge. And so can you go into that a bit? Tell us a bit about Lightbridge's mission and its work in advanced nuclear fuel development, but also maybe can you sort of trace the evolution of that mission? I know thorium was where we first connected, but give us a sense of kind of how that mission has evolved over time and what it is you're focused on now and where you see the opportunities.
Well, before there was Lightbridge, there was a company called Thorium Power that was looking at using an element called thorium in making fuel for reactors. And there was interest in thorium around the world that was driven for many reasons, including that India was not able to access nuclear technologies and uranium on world markets, but has a lot of thorium in the ground, and was very driven to try to use thorium in reactors. And there was a notion that uranium was very limited. We might be running out of it eventually, and we could use thorium in reactors. And the way thorium works is that you need to what's called seed it. It's what's called fertile. It's not what's called fissile that will produce power. And using what's called an accelerator or using neutrons from uranium in a reactor hitting the thorium, you can get it to become a form of uranium that produces power. And that's something that we had been looking into. And a lot of people ended up moving away from thorium, including us, partly because India entered into this nuclear deal with the US during the George W. Bush administration, where India could access nuclear technologies and uranium on world markets. And that's what India's been focusing on since. And because we found that the benefits we thought we could get from thorium relating to a more energetic fuel, one that could last longer in reactors, one that could provide tremendous safety benefits, there were ways we actually thought were better without using thorium, but using uranium in a different form. And we also found that uranium kept being discovered more around the world, and there's just so much of it from Australia to Canada to Kazakhstan, and now much more uranium mining in the United States and other countries, that there's really not a sense that we're running out of uranium. And if we do go to reprocessing of this used fuel, that's a tremendous source of uranium there too. So the move away from thorium and toward a very different fuel to accomplish the same missions better was really an evolution that led to Lightbridge. And it was based on talking with some large nuclear utilities that were looking to increase the power output of new reactors, and in particular, increase the power output of their existing nuclear power plants, while enhancing safety further. They're always focusing on safety. And we started working on ways to reimagine, to redevelop the nuclear fuel for reactors from scratch in a very different way. Even the thorium was kind of similar to the old uranium fuel, which is these ceramic pellets of uranium where a couple of hundred of those are stacked up inside a metal tube. And even thorium fuel was very similar to the uranium fuel. It just hasn't really changed much in 60 years, just very slight tweaks. But Lightbridge went in a very different direction of let's start from scratch. Let's not use pellets. Let's not use tubes. What can we do that can meet what the utilities are looking for to get a lot more power out of their reactors with better economics and even enhanced safety? And that's what led us to move from ceramic or oxide uranium to uranium in a metallic form, from pellets stacked in a tube to an extruded rod with several zones in it that are metallurgically bonded to each other in an extremely high-tech product where we invented the design of the fuel rod as well as the production method for it. And we've started basing this project at Idaho National Laboratory, which is the designated United States lab for nuclear energy and nuclear fuels, and benefit from tremendous knowledge and facilities there and support from the US government. And it's remarkable to think that it's only been 4 months since President Trump signed the nuclear executive orders in May of 2025. Lightbridge has been moving at a speed since then that's really unheard of in nuclear. So we're working at Idaho National Laboratory, where since May, all of the following has happened. Fasten your seatbelts. We received physical highly enriched uranium from the US Department of Energy. Very few companies in the history of the world have received highly enriched uranium from a government. We, working with Idaho National Laboratory, produced nuclear fuel samples using that highly enriched uranium. Those fuel samples passed being qualified with Idaho National Laboratory. We were approved for what's called fast testing, which is something Idaho National Laboratory invented. It's an acronym, Fission Accelerated Steady State Testing, that means literally faster testing of nuclear fuel in a reactor. And having that highly enriched uranium means there's more neutrons. The fuel can be tested faster in the reactor. We've been approved for the experiment for going into the reactor. We're supposed to go into the spring outage in the first part of 2026 in the reactor, but it looks like that's being accelerated, and we could possibly be in the reactor in November of 2025 instead. And these are all things that have happened in the last 4 months. And this is really industry and government working together quite quickly, quite safely, using advanced technologies, advanced methodologies to really do things faster than they've ever been done before in advancing new nuclear technology.
And what would you put that down to? Is it the fact that you've had a working relationship with Department of Energy for a while. You have your engineers and expertise and a track record there, or is it a combination of that plus this sort of new surge of energy from the laboratory side or government side rather?
Yeah, it's also benefiting from the legislation that's been passed by Congress and signed into law by the president, benefiting from the executive orders, which are binding on the executive branch of government. And I think in the end, really pressure from these giant companies, these hyperscalers that need the power and are interested in nuclear power, that's not specifically making them look at Lightbridge and the specific test we're doing at Idaho National Laboratory, but that is getting the Department of Energy and the national labs and the companies like Lightbridge very motivated to work very well together. And in nuclear, there's a saying that you should take a long time to plan and then execute quickly. So what you don't want to do is start building a reactor that you haven't finished designing. You want to spend a lot of time planning it and then build it quickly. And it's like that with what we're doing now. We've been preparing for this moment for a long time. We've been very detailed in getting to this point with our fuel development, with brilliant people at the company and at Idaho National Lab who are very excited about this work, working on this project. And when this moment arose and the government was looking for ways to move more quickly, we're ready. And other companies are too. It's a remarkable moment in nuclear.
So it's a convergence, and I suppose when you look at these four milestones, and mention the the fast testing, the new fuel samples, the approval, all of those key four milestones. Which is the most critical to you as a company right now? Which is sort of the one that you would point out and say, okay, this is really important. This is what's going to help us, drive us forward in the next, 6 to 12, 18 months, and so on.
It's getting these samples into the advanced test reactor at Idaho National Laboratory, hopefully in November and certainly by the spring, that the physical testing and demonstration of properties is what's most important. This is not modeling and simulation. This is not computer simulation. We certainly have a lot of that and other testing outside of reactors and analysis outside of reactors too. But there's nothing like the physical properties, the thermophysical properties, as it's called, of the fuel in a reactor being tested to produce the data that the Nuclear Regulatory Commission will need to license the fuel and that the utilities will need to be able to decide that they want to use the fuel and license it with the Nuclear Regulatory Commission. And also that particular milestone means that all the other ones before it have happened, including that you produced these samples and that the experiment was approved for going into the reactor. So it means all those other steps have happened. And what you see of in nuclear and some other technologies is sort of vaporware, PowerPoints. Are they actually producing something? And this is different. This is something that is so exciting to the Lightbridge team, to the Idaho National Lab team, to be producing physical product and physically testing it in what I believe is the world's largest test reactor that the United States is making available to us.
And presumably because you have that real-time testing, understanding the behavior of that fuel and in those conditions, are you able to, would you say in a shorter time frame, potentially tell the Dukes and the Constellations of the world, hey, our fuel performs at this level, with this level of efficiency, with this level of power output? Is that sort of where you're going to be able to get to with the data from the testing if you get into the reactor by November?
Yeah, and we're very confident we will, and it's also very important as I said, that we spoke with utilities from the beginning to get their input, and we're still in contact with utilities. You don't want to go to a utility and say, hey, here's results of a test we did, and have them say, well, go back and do it this way to get this different look at it that we'd like to see. So it's very important to us to get input from utilities along the way too. And obviously for what the NRC needs too, and have some interaction with the NRC, the Nuclear Regulatory Commission. So this data, by using highly enriched uranium in this fast test, completes the experiment and gets the data, within that part of the reactor where the fuel is, faster, sooner than you otherwise would have with lower enriched uranium without using this fast methodology. And that is something that is quite remarkable, that this can be brought in sooner than it could have been without this kind of government support.
So in a way, I mean, it's a much the time sort of issue, which we've talked about, whether it's developing a reactor and getting that done, the time frame of developing a fuel that is tested and safe and everything. As you mentioned, you want to plan for a long time and then execute quickly. Makes sense. But it's sort of the speed of everything else coming together, which I guess is making this all work. When you look at the landscape right now, and I mentioned some of the sort of new developments out there, small modular reactors and micro reactors and so on, in addition to, of course, some of the new reactors that have been announced or that are planned, as in New York State and others. Is it the view that Lightbridge's fuel technology is sort of a something that can be applied in any type of reactor, or is it where does it play in terms of input into the existing infrastructure or the new types of reactors that are emerging?
The Lightbridge fuel is designed to work in all of what are called water-cooled reactors, which include what are called light water reactors, that include pressurized water reactors, including in some countries what are called VVER reactors, and also in boiling water reactors, and also in pressurized heavy water reactors, including what are called CANDU reactors in Canada. And all of that is almost all of the nuclear power generation in the world today. The Lightbridge fuel could work in those types of reactors. And it's almost all of the nuclear power generation that is under construction now or on order or planned in the world. There are types of reactors called advanced reactors and Gen 4 reactors that would be very different technologies that tend to be smaller reactors, including, you mentioned, microreactors that the fuel would not be used in. And a lot of those are either for, very small power for, say, hydrofracking or a small application, not powering a city. Lightbridge fuel is for electricity, for the grid, and maybe for behind the meter, it's called, for a site with data centers or big power needs. And the small modular reactors, are mostly reactors that are just smaller versions of the current technology, like pressurized water reactors, and could use our fuel and benefit it. And the more what's called advanced reactors include producing very high temperature heat or steam for industry, and those would use different fuels. So, for example, one of the small modular reactor developers is NuScale. And the Department of Energy is fully funding 2 studies, one at MIT and one at Texas A&M University, looking at the benefits of using Lightbridge fuel in the NuScale small modular reactor. So we expect, even though we started out really looking at the large existing reactors for the utilities before small modular reactors came along, that is additive to our market, and that we will be able, we believe, to help these reactors very much. And I think you'll see some results coming out of these studies in the next year. And MIT has already reported on some of the benefits of Lightbridge's fuel for these SMRs.
Hmm. So the addressable market is growing, and you're growing with it, I suppose.
Yes. And first of all, you have a lot of reactors that were supposed to close, but are instead getting 20-year license extensions, then another 20, maybe another 20. So those are staying within the market. And then you have within existing reactors, the utilities looking to add more power from them, which is really the sweet spot of our fuel. Add more power to existing reactors and sell that to data centers or your other customers that need more power. You have some reactors that were partly built and abandoned. There are two in South Carolina. There's one in the Tennessee Valley Authority that could make more sense to complete using a more efficient fuel immediately or after they start operating again. And of course, there's building new reactors, and the United States is part of a global pledge to triple nuclear by 2050. And that's only 25 years from now, triple nuclear in the world by 2050. And the United States is committed domestically to quadrupling nuclear in the next 25 years. So that's going to be power upgrades to existing reactors, finish uncompleted reactors, keep licensing the existing reactors, but mostly that's going to end up being building new ones. And there's great economies of scale to large reactors per unit of concrete, per unit of steel, the capital cost, the lower the cost per unit of electricity produced, the bigger the reactor generally. So I think there will be a lot of these big reactors built, like the two Westinghouse AP1000s that opened in the last couple of years down in Georgia in the United States. And I think we'll see a lot more of those, and that the Lightbridge fuel will be very good for these markets domestically and in export markets.
So fundamentally, with the sort of existing reactors, that you're able to go in and essentially, ideally, propose a fuel that is going to be more efficient, but ultimately the key play is really the power output, right, to meet the surging demands. And it seems like with the small reactors that are coming online, that also they could benefit from this as well, even if the need there is smaller, but they could also benefit from higher power from the get-go. Is that sort of a correct estimation?
Right. And in the end, they might overtake the big reactors in total generation as over time, these small reactors are having the major modules, the major components produced in factories or in shipyards. And this is more like making a machine in a factory than it is like a big construction site. And as they hone those and you start getting some winners that gets to what's called nth of a kind, where they have known costs and timeframes to deploy and could be deployed in large numbers, those might have very attractive economics too. And, for example, in World War II, the United States ramped up dramatically the production of military aircraft, fighters and bombers, producing over 300,000 of them in less than 4 years. There was no German or Japanese military strategist who imagined that would happen, who thought that could happen. And that was assembly line factory production for the first time ever of aircraft. And they were produced in what some people described as a miracle, a bunch of parts going in one end of a plant every day, and airplanes, one after the other, coming out the other side and going down an airstrip and taking off to go to the war effort. And 300,000 of them produced. And so these SMRs, these small modular reactors, could end up being like that. They're not there yet, but they could become something that with modular production and modular construction, could become an enormous market. And there are some ways where our fuel could be even better for them than for the big reactors, particularly for the ones like NuScale that don't have pumps, that have what's called natural circulation of the water circulating through the plant without the need for pumps to move it, where our fuel might even be more efficient there than the big reactors our fuel was originally designed for.
So in a sense, I mean, you're sort of, as much as you're testing the benefits and the sort of the benefits capabilities of the fuel in current reactors now, you're also kind of seeing, okay, where the market is going, where the innovation is going with the smaller reactors, and being able to address their needs as well. I mean, is it conceivable that the 20% energy mix that we talked about earlier in terms of U.S. Nuclear, part of the overall energy mix, is it doable to say that might increase to 40%, 50%, just given?
Yeah, if we're talking about quadrupling nuclear in the United States, why not? Now, it's remarkable that nuclear has remained at about 20% for so many decades, given how much electricity use in the United States has grown during the period. The amount of nuclear power has grown partly due to building new reactors, but mostly due to getting the existing reactors more efficient, getting more power out of them. And that's where we think Lightbridge will be able to help the reactors make a much further, greater leap going forward. But for the most part, by staying level between about 19 or 20% of electricity in the country for decades, as electricity use has grown dramatically, it's been through operating the existing reactors much more efficiently and getting more power out of them. And as we go forward, one reason why my personal focus is on the existing types of large reactors is that they exist, that there are hundreds of reactors that are operating today that potentially could use Lightbridge fuel. And everything else we talk about is something that's not yet fully licensed by the nuclear regulatory, not yet deployed, not yet in a position to use our fuel because the reactors don't exist yet. But potentially over time, those could overtake the large reactors as the main source. And as we go through this massive electricity needs in the United States, increasing, like for data centers that use as much power as cities, I do think that not only overall will nuclear keep up, but I think it will get ahead of the curve, and you'll see that 20% increase over time, and potentially quite a bit.
And of course, I mean, there's as much of a demand domestically here in terms of the data centers and everything that we talked about. I, for example, am following the story closely of some of the huge surge in needs, particularly in the Midwest or upper Midwest, on energy needs and costs and actual utility prices. So I think the demand is there, and I think it's maybe beyond industry, and it's now coming down to residential consumers who are now looking at their energy bills and realizing, well, everything is going up, right? So there is the domestic landscape in terms of the demand, in terms of the potential, and then there's also the global, as you mentioned, where in some cases, particularly in parts of Europe, where nuclear has been a mainstay, right, in France and so on. I find it interesting now in the case of Germany, where nuclear phased out, of course, under Merkel, but it's sort of trying to mount a comeback in light of some of the needs there. I know it's still a process, but there seems to be, again, this overall global surge in demand for it. Globally, where do you see the biggest opportunity? Where do you see particular inroads for Lightbridge and the technologies that you're developing?
Right now, the United States, which has more operating reactors than any other country in the world. Also, one link between the U.S. and global markets is that there are many people, including in government, who see as an energy security issue that increasing nuclear energy, nuclear power in the United States frees us up to export some of our natural gas in increasing quantities in the form of liquefied natural gas to allies that are looking to wean themselves off Putin's natural gas. And the more we use nuclear in the US and export gas, that's not only good business and good revenue sources, but it's good for our national security and those of our allies. You mentioned Germany, which closed down its reactors, and now there's some very serious looks at reopening its reactors. But Germany never stopped using nuclear power. Germany is not an island, and it's surrounded by countries that produce nuclear power, including France and the Czech Republic and Sweden. And they've been exporting nuclear power over the grid to Germany this whole time. So Germany stopped regulating the reactors and closed the reactors within its borders, but still used nuclear power all of this time as part of its diversified energy mix. And we're seeing, several countries, particularly Russia, China, France, South Korea, and US, prioritizing deploying nuclear domestically and becoming bigger exporters in nuclear power. We're seeing India start to move to try to be like that to some extent, Argentina and other countries, Canada. And so this is a globally significant and growing business that many countries view in many ways as being strategically important to the countries, quite rightly, and part of this great power competition that the United States is absolutely set on winning, including by quadrupling the use of nuclear power in the next 25 years in this country.
And we sort of stay there with the geopolitical context, because, of course, you're right. On the one hand, you have this incredible global competition, not to mention a changing world order as well. So that component of power, energy, and global power and political power, geopolitical power is converging. One of the interesting chapters in the Lightbridge story, and I was there just for a small portion of it, but I remember that part of your consulting side of the business, where you advised the United Arab Emirates, UAE, on their civilian nuclear program. And I wanted to kind of get your take on that in light of what we saw this past few months and certainly in Iran and Israel war, but some of the concerns over civilian nuclear energy in the Middle East and the issue of nuclear war and so on. But can you sort of provide some insights into the role that Lightbridge played in terms of the UAE?
Well, Lightbridge wrote the strategic plan for nuclear power in the United Arab Emirates, and that included helping to form the nuclear generating company and the nuclear regulatory authority. That included helping to write the national policy on nuclear energy and the nuclear law, and help guide them up to and through the deployment of the reactors. And the UAE has been a real leader in doing nuclear energy right, at prioritizing principles of meeting or exceeding the world's highest standards of nuclear safety, security, non-proliferation. They've been extremely cooperative with the International Atomic Energy Agency. They've really been a shining light in how to do nuclear right. And a lot of other countries are looking to try to emulate what the UAE has done and learn from the UAE. And the UAE is starting to reach out and help, some other countries too. And the UAE, was looking at nuclear energy for many reasons. And part of it was that they were importing natural gas from Qatar and were looking to become energy independent. Part of it was as Dubai and Abu Dhabi and other cities and industries were growing in the UAE, they didn't want the air in their cities to be like Beijing or New Delhi. They wanted clean air. There's a program, and nuclear helps with clean air, it's nothing into the air. There's a very important program called Emiratization, of training the people for the future in the UAE, and a nuclear power program is very good for people being trained to be educated in an industry of the future for the country as engineers and in many other high-tech skills and jobs. And the UAE, has oil that it drills every day and it exports. And eventually, within the small territory of the UAE, that will start to wane, even if there's more oil found elsewhere in the world. And the UAE has been doing an excellent job of transitioning its economy to be just hydrocarbons based. I think the economy is now less than 30% based on oil and other hydrocarbons. And that number is going down, which is in the right direction. And so by exporting the oil as much as they can and using that revenue to diversify their economy into modern industries like computer chip making, satellite designing, all the modern industries going into the UAE now with Emirati citizens in leading roles and working in these projects is transitioning the economy. So instead of burning up as much oil every day to produce power, which is what the UAE had been doing, make a lot of that power with nuclear instead, export more of that oil, and use that revenue to train their people, diversify their economy, and plan for the future. And the UAE, again, has really been, sort of a guiding light in how to do this in such high-level cooperation with the International Atomic Energy Agency, with responsible countries like the United States, and has just done this program extremely well to the point that other countries are now looking to the UAE for guidance.
So the blueprint is there from McLean to Abu Dhabi. The Lightbridge journey. We're I know coming up to time here, and I wanted to just sort of get your, now we've sort of talked about what you're doing as a company and how you're developing the fuel, some of the key developments in the landscape in terms of the, small reactors and innovations and so on, government action and support that's converging and really putting a new surge behind this renaissance. So what would you say are some of the things that you would like to see happening, say in the next couple of years that you think will really define this period, and we can look back and say, the promise of that nuclear renaissance has now been realized. What is it that needs to happen, between, let's say, the next few years, and what sort of role do you see Lightbridge playing in those sort of, let's say, catalytic events?
Yeah, part of what's heartening to me is just how excited the engineers are at Lightbridge, at Idaho National Lab, working on this project, how we are growing, we're hiring new engineers, and just how many resumes we're getting, just how many people want to be associated with Lightbridge or working in the nuclear power industry. We're seeing nuclear engineering departments at universities growing and universities adding new departments that they didn't have before. We're certainly seeing investment and interest up to the level of these hyperscalers and giant investment firms that are moving into nuclear for the first time and in significant ways. And we're seeing new technologies being prioritized and moving out of the lab and toward commercialization like Lightbridge. And I think that the government support has been excellent, and I see that continuing based on meetings I've been having and many people have been having, where the people from the executive branch to the legislative branch are talking to industry and asking what we need and helping to provide it. And I think that the government making its resources available to industry, like this highly enriched uranium from the US Department of Energy to Lightbridge, like the FAST methodology for testing from Idaho National Laboratory to Lightbridge, like the Advanced Test Reactor, this multi-billion-dollar asset of the US government being made available for Lightbridge to use. And in many ways, it really is something that has to have government support. We're not going to, as a nation, win internationally on nuclear power against Chinese and Russian state-owned and state-backed companies without some support of our government. And our government has really stepped up. And a lot of this is in non-cash important ways, as well as some cash ways, but really some non-cash ways, like letting us use these government facilities. So we're looking forward to seeing more of that. We're looking forward to having, groundbreaking ceremonies on facilities to produce the fuel, ribbon cutting ceremonies, and first demonstrations in commercial reactors.
Well, it's you certainly got your hands full, Seth, and I think what one can say that it's clearly an inflection point, for so many reasons, and I think it's a good one. I think as company that, for us anyway, that works in sustainability and we're always dealing with climate and energy. It's always good to see innovation. It's always good to see solutions that are addressing some of the key challenges that we have. And I always say energy is power and power is energy. So I think that it's great to see where Lightbridge is going. And I'll leave, my final question is always the easiest one, is the most difficult one, which is, you work in this industry that's transformational, that's driving, that has really huge opportunity and as well as challenges, but is transformational. And as you sort of, get up in the morning and, go to work, what is it in terms of a legacy? What is it that you want to sort of leave behind with the work that you've been doing with Lightbridge?
What we focus on, that we want to bring the power that the United States, the world needs more safe, reliable, clean power that is needed for almost everything. And what we are developing in this Lightbridge fuel technology will do that, we believe, and we're going to demonstrate that in the programs we're in now. And so being able to see the Lightbridge fuel in commercial reactors producing significant amounts of the power that the world needs and employing large numbers of people all through those supply chains up to the fuel working in those reactors, and all kinds of people and industries benefiting from the power. That's what we want to see. And we're looking forward to visiting large numbers of plants that are using the Lightbridge fuel to power, not just data centers, but homes, hospitals, everything that's needed, medical research. So, we're very energized about what we're doing and very excited about it.
Well, we hope to follow this up, because there's more chapters to be written, and certainly look forward to continuing the story and keeping track of where things go and continue the conversation.
I look forward to it. Thank you very much, David.
Thank you very much, Seth Grae, Chairman and CEO of Lightbridge, and we will talk to you soon.
Thank you. Goodbye.
Bye. I hope you've enjoyed this latest episode of the Global List podcast. We're off to fuel the jet for the next adventure. Until then, be sure to subscribe wherever you listen to your favorite podcasts, and be sure to follow our new YouTube channel at the GL Podcast, new Instagram account at the Global List Podcast, and our new TikTok at the GL Podcast. As always, stay tuned for more unexpected journeys with leaders, thinkers, and innovators.